All right, everyone. Thank you very much for coming to my talk. Good afternoon. I'm particularly flattered that you all showed up when it's the last talk of the conference and you could be out enjoying all of the many cultural experiences that Sunnyvale has to offer. I mean, like, Sunnyvale is the home of the one and only haunted Toys R Us. Supposedly haunted by the ghost of a farmhand who died in the orchard that became the Toys R Us. It's not too late to get your late Halloween thrills in, your early Christmas shopping in. Also in Sunnyvale was the Blue Cube, full of former military Air Force installation, full of people probably tapping data center links. Actually, it was demolished a few years ago, but you can go look at the empty space and use your imagination. But the thing that people really come to Sunnyvale for are things like this. Yes, yes. The only housing for kilometers in any direction that is less than $1 million. This is a particularly progressive instance, you can see, because it's literally in someone's backyard. All right. So presumably you actually want to hear about integration testing. So let's move on to that part. So I work at Dropbox in our developer infrastructure group. So that means we're responsible for everything that our engineers use to build Dropbox. So everything from version control, build systems, CI systems, and the processes that those used for. So to use a terrible mixed metaphor, we produce the box cutters and the glue that our engineers use to make premium cloud storage solutions. We're all hoping the cardstock price will be high. Of course, they either use the box cutters to make premium cloud storage solutions, or they cut off their pinky fingers and are unable to use Emacs ever again. So we're going to talk about integration testing, and it would behoove me to actually define what I'm going to talk about. So for the purpose of this talk, I'm going to define an integration test to mean a test that requires more than one process running in order for the test to work. So many people would disagree with this definition. They would be correct. But I'm going to adopt this definition for this talk because that's going to be the focus of it. So our story starts back in the medieval ages in the year 2016. So back in those days, if you were a Dropbox engineer and you wanted to run something on our CI system, what you would do is you would write a shell script, and then our CI system would run that in a container somewhere. So that was very flexible, but it did mean that everyone had to do everything by hand, from building to testing to collecting results. And so people adopted many terrible ways to do this, such as using shell job control, the native init systems of the underlying systems like Upstart and Latent systemd, and configuration management systems like Puppet. And partially as a result of this, but also as separate issues, many of our tests were just wildly non-hermetic. We had tests running against our production servers, tests downloading random code from the internet and executing it. And all of this spilled into our development environments, some of which used some of the same CI shell scripts. So to give you a taste of the things we were doing with, here is our Puppet module for setting up MySQL. So as you can see, there's a service definition for MySQL, which handles MySQL being in multiple places, maybe. But this is, I literally pulled this code out before deleting it. It was actually there. But just starting MySQL isn't enough, because it might not be able to serve requests immediately. So you also have the MySQL health check, which is the crappy shell script which Puppet retries up to 50 times in order to see whether MySQL is actually running or not. So Puppet is very, very good at making sure a file somewhere on disk has some particular contents, but it's not a very good service manager. But we had hundreds and hundreds of these kinds of things in our Puppet code base, setting up and running services. 2016, we had all this stuff. In the meantime, we're a growing company, lots more engineers, a lot more code, a lot more tests, and a lot more services. So we're getting more and more of the shell scripts, Puppet modules, and it was becoming increasingly untenable. In the meantime, we were happily migrating all of our server-side builds to Bazel, and we were wondering, how can we get all these integration tests into Bazel? And so this talk is a story of the the framework that we ended up coming up with to run our integration tests within Bazel. To present that, we call it the services framework. I have a series of examples which shows how you might run an integration test at Dropbox. So you may be familiar with the Echo server. So the Echo server is a classic example in system design of a server where you send it some request and then it sends you back the request what you sent to it verbatim. So it's a very democratic, egalitarian kind of service. You only get back what exactly you put in. So we're going to be considering a modern reincarnation of the Echo server, which has been adapted for our modern times. It's called the Echo Chamber server. So here's the implementation of the Echo Chamber server. So we're not going to be worried about too much of the details here. It's mostly just boilerplate for setting up a Tornado server. So the Echo Chamber server echoes back what you send to it, but in all caps and with a hashtag. So here's the endpoint, which actually does that. And then there's also a health check, which we're going to use, which can tell us that the server is actually up and able to send requests. So if we fire this thing up in a terminal somewhere, then we can curl it to see what it does. So you can see the underlying neural network might need some more training, but otherwise it seems to be serving 200s. So we've seen that it works by curling it manually, but being responsible software engineers, we want to write a test to make sure that it continues to work. So here's something which we might write. So here's the Echo Chamber server test. And so basically this is posting to the server, seeing what the response is, and then asserting some property of the response. And you can see one part about this test is that it requires the server to already be running before the test is run, because it just assumes that it's there in the background so it can post to it. So our testing framework would need to make sure that this service is running before we're actually able to use it. So let's see how we would go about encoding that in our services framework. So the first thing to do is actually just make a binary target for the Echo Chamber server. So we can just use the straight built-in pi binary rule. Even though it's terrible, it's sufficient for our purposes here. So that's just straight built-in Bazel. And this is even the same thing that we could deploy to production if we wanted to, where our stuff starts coming in is this rule down here, the service daemon rule. So this declares a service which is run by starting this executable given by another target. So that's the exe attribute here. And then the service framework will know that the service is healthy once it responds to this HTTP health check. So that health check is very important. You would never go to work sick, so don't let your services do so either. And so now we have the service binary itself and a service definition of it, which describes how to run it in a test. And so now we can actually write a test which uses a service. So to put our test class into Bazel with this service, we use a rule called PyTest with services. So we can't use the built-in service or the built-in test rule, because we need our test driver to actually start up a service, do some extra work, which the built-in one can't do for us. But once again, it tries to follow as closely the built-in rule. So these are all built-in attributes of PyTest rule, and our rule has the exact same semantics. Where it gets interesting here is now we also have a services attribute, which declares a dependency on the service rule, which we defined earlier. And so now the test driver will know that it has to start up the service, make sure it's healthy, and then finally execute the test. So this is the most basic example of our services framework. Of course, one of the more powerful things you would be able to do with services is have services which depend on other ones. So we can also express that with our framework. And that way, the way that works is you simply add a deps attribute to the services rule. So suppose we had a variant of our Echo Chamber server called the Enterprise Echo server. So obviously that needs a lot of dependencies. So In my case, I meant has the XML spigot, and of course, services can transitively depend on more service. So no doubt, XML spigot depends on JBoss or something. And the test driver now arranges to make sure all these dependent services are started up before actually starting our enterprise echo service. So we're encoding the dependency graph of services within Bazel. Another thing that we have, which is kind of a variant of services, is just one-shot services, or what we call service tasks. So it's very common in the setup of a test that you just need to execute some script to create some part of the test environment, like add fixtures to a database or run migrations of some sort. So we support one-shot services, which are not actually daemons which need to run during the course of a test, but rather scripts that run and initialize something. So the service framework just runs these and then waits for them to finish rather than running a health check or anything. For more advanced use cases, we support dynamic control of services within tests. So this is very useful for tests that want to check what happens when a particular service goes down that they depend on. So here's a piece of code, or a test that I pulled from some of our Go infrastructure. So this test wants to check what happens when a zookeeper goes down to the code under test. So for all of our server supported languages, we provide a special library called svcctl, which allows you to control services during the test run. So you can create them, restart them, and stop them. So this is an example. Down here, you can see in svcctl, it calls create service, and it passes a service def. So this is actually a protobuf, which is a representation of what is in the service rule in Skylark. And servicelib takes care of talking to the daemon that's actually running all these services, creating the service, and making sure it's healthy before returning. And then with the object that's returned from that, the test is able to start and stop the service that it has created. So as I've alluded to, this is all the magic is kind of mediated through a special daemon, which is running during the test called the service controller, or svcctl for short. And this is a tool which takes a protobuf description of all the services it needs to start. So that's basically directly serialized from the Skylark descriptions, and then starts up all the services in topological dependency order in parallel if possible, and also takes care of some other administrative tasks like service logging, so making sure the standard error of services is prefixed with their name, so they're disambiguated within test logs. So what have we gained from all this? Well, we now have a standardized declarative configuration of all of our tests, and it's encoded in Skylark. And the great thing about Skylark is that it doesn't let you do anything. So it's not like Puppet where people can execute random shell commands. And so now our service environment is reproducible anywhere because you can just run Bazel to set it up. So it's the same on CI as in a local development environment, which means there's no more of this like, oh, well, I can't reproduce this test failure locally because CI is slightly different than me. That doesn't happen anymore. And since it's a declarative configuration, it's Bazel queryable. So it's very easy to answer a question like, what service depends on mine in tests? That's just a Bazel query away. And it's also queryable by machines. So we implement selective testing where when a change is being tested, we only run the tests which can possibly be affected by the files that have been changed. And that's all implemented through Bazel query. It also dramatically reduces our support that we have to do for customers of developer infrastructure because the answer is almost always the same. So if someone comes to us and says, how do I run my Go unit test? We say Bazel test. Similarly, if someone says, how do I test my Python service that depends on 5 Go services? We say, well, make sure there's service definitions for all the Go services, and then use Bazel test. And this extends quite logically to things like, how do I run my Frankenstein ML app that synchronizes a JVM Go, TensorFlow, LibreOffice, and a blockchain? You think I'm exaggerating, but it turns out all it takes is like a goat sacrifice and a subsequent vision to tell you what linker flags to use to create this thing. But regardless, what we say is Bazel test. It's good to keep Frankenstein in the sandbox. All right. So you might think that we were just like a broken record stuck on the Ode to Bazel track, but sometimes we have to vary answer. Like if someone says, how do I run my ping script against production Dropbox.com in CI? Well, then we say, no, 1,024 times no. If there's one thing we've learned in this team, it's just say no to non-hermetic tests. We spent a huge amount of time cleaning up all the non-hermeticity in our test suite and builds, and we really like having our tests be deterministic and isolated from the environment and repeatable, and we never want to go back to our dirty old ways. Okay, so another thing we've been able to do with the services framework is leverage it to describe an environment for interactive development. This is not something you can really do with Bazel out of the box, because Bazel is kind of a traditional command line thing where you run a command and then it returns you an error or a success. So we have a tool called iTest, which lets us run services and service-based tests. So if I have a service-based test, like the echo chamber service test, and I use the command iTest run, this will build the test through Bazel, start all the services in a container, and then run the test in that same container, and then finally pop me into a shell in that container with all the services running. So this would be more interesting if the test had actually failed. Then I could poke around in the container, hit the services myself manually if I wanted, restart them. We provide a little command called svcctl, which actually talks to the service controller as necessary, and rerun the test in order to debug it. And then when I'm done looking at that in the container, I just exit out of that shell, and I'm popped back to my normal shell, and the temporary container is cleaned up. So that's a way to interactively debug these service-based tests. We also use it just for normal application development. So we have, if using the iTest start command, you can actually just start a tree of services in a background container, and then continue to hit it with however you want. So when people are actually developing a web app at Dropbox, they run iTest start of like my web app target, and that starts up the web app and all the necessary services which are needed to run the web app in development, like a database. And then people hit it with their web browser and can see what they're working on. So in order to facilitate rapid development with these service trees, once a background service container has been created, we also provide a reload command, which looks at all the files that have been changed and only restarts the services, rebuilds and restarts the services that have actually been affected by whatever the user has been changing. And then finally, when the user's done with the background services, they can shut down the background container and clean up any dirty state they may have. So this would be a sleazy marketing talk and not an engineering talk if I didn't tell you about all the bad things that this causes. So to start us off, I have a picture of a Bazel process caught in the wild using 87 gigabytes of RAM on a 64 gigabyte machine. So one thing is this services scheme relies on greatly on the Bazel sandbox. So Bazel sandbox was probably mostly intended to keep your like nasty gen rules well behaved, but we fully utilize the fact that it uses networking containers and mounts everything in that the test requires. There's also a bunch of flags which you can use to configure the behavior of Bazel sandbox. We pretty much pass them all multiple times if possible. And we use features like requires fake root, which allows the the process in the container, the test process, to think it's assuming UID 0. And because the sandbox is supposed to be kind of like a simple general wrapper, it lacks some features like debuggability, which you would need in a more featureful container system. Luckily, this is mostly addressed by our iTest system, but it also causes problems for things like nested containerization, because the Bazel container basically takes your only level of possible containerization, and so we can't test any of our tools which require nested or containers of their own within the Bazel sandbox. Another limitation we run into with this is since all the services that you end up having in your test are in the same build, you can't pass different Bazel flags to any of the different targets in your services tree. So if you want to have some service with compiler flags Y and another service with compiler flag Z, you can't really do that with Bazel. So the gods of dynamic configuration upstream may eventually fix this problem for us, but for right now, there's a number of workarounds you can do, like, well, you build one service in a first build, and then you kind of like inject that into the later build as a binary blob. Or if you control your own rules, you can do things like generating multiple outputs for all the possible flag configurations you're interested in. None of those are quite as good as true multi-configuration build support would have. So those are kind of the primary technical problems with this services framework. But the thing that really hangs over our heads, keeps us up at night, is the question: did we make integration testing too easy? So we sort of took this problem, which was like starting up services in CI and running tests against them is not reliable. We made it very reliable, but it turns out that's only one segment of what makes integration tests unreliable. And sort of now that we've made the activation energy of creating an integration test much lower, you just like add some services to your test rule. It's very easy for people to create integration tests before they realize their total cost. So because of the power of the declarative service configuration, people can like reparent trees of services and like cause thousands of tests which depend on them to become slower or faster or use more memory and stuff. So some fun statistics. So following Bazel, we have our service controller actually compute the critical path of service startup. So here's an example of a particularly large service target that we have. So you can see it took 58 seconds to start up all the services for this target. So that's 58 seconds before like a test would even begin doing anything useful whatsoever. So you can see there's many targets which are using more than 1 second to become healthy in this critical path, and we ended up starting 107 services up 107 services in this entire process, and some of this is just because these services because they're literally the production ones. They're like not optimized to start up fast in CI, and they like go and verify some property or allocate a lot of memory in anticipation of receiving production traffic. But there is a fundamental growth problem, which is that if you keep cramming services into a container, it's going to get too big at some point. So these fatal attributes have started appearing all over our code base. Bazel is very cute, and it believes that eternity is 1 hour. I'm sorry to say we know that. There's also a flag to change that. So like there's certain workloads which are incredibly problematic, especially for memory. So if you have anything which is using like a thread sanitizer, especially it's incantation in Go race, that instantly like quadruples your memory usage of that process. So even if you have 60 or so leanish Go processes, if they're all using Go race, that's going to earn you an enormous size. Then we went and learned about the literature on integration tests. So perhaps the most ideological of these is this Rainsberger article called "Integrated Tests Are a Scam." But there's also this article from of all places, the Googs. So on the Google testing blog, they also want us to say no to something. And the Google testing blog post about saying no to more end-to-end tests brings a lot of data to bear that on the problem that actually they're not so helpful for detecting problems, and they do cause a lot of developer pain. And certainly the experience in this blog post jives a lot with ours. So that means our next project is getting people to not use our services framework by writing unit tests. So this could be a whole talk on its own, and we're just getting into it. Maybe I'll write a chapter in my memoirs about it. But I can discuss for a few minutes some of the prongs we're looking at. So one is just education. So this is a diagram which was conceived by Mike Cohn called the testing pyramid, which is supposed to indicate how many of each kind of test you're supposed to have. So up here, the creepy all-seeing eye is manual testing. So you don't want to have very much of that. At the bottom, you have unit tests, which are supposed to be the core of your testing framework, from which you do most of your development on and achieve most of your coverage. And then integration tests of various sorts are kind of in the middle. So right now, we show this diagram to our engineers once in onboarding, like 45 minutes into an hour and a half talk, so no one ever remembers it at all. But we're thinking of doing some more repeated, spaced repetition learning by repeating constantly. And we also want to do things like requiring, as part of owning a service Dropbox infrastructure, you have to make it so people can test with your service, or test things that depend on your service without actually using your service. So provide things like fakes. We also want to provide incentives in our processes where if you work on a code base that has good tests, where good tests is defined as being unit tests, then we'll make it easier for you to land your code and faster. And kind of the stick part of that incentive is that we'll carefully track everyone's CI resources, and people with particularly egregious CI bills will hear it from someone in management. So that's all I have.